Good day to all. Myself, Samuel Jeffrey, working as Assistant Professor in the Department of Automobile Engineering in Hindustan College of Engineering and Technology, Coimbatore. In this particular video, we are going to learn about the braking system basics. This is my personal profile. I did my BE Mechanical Engineering in the same institution, Hindustan College of Engineering and Technology. After that, I have completed my ME Engineering Design in Government College of Technology, Coimbatore. Currently, I am pursuing my PhD in tribology, and my areas of interest are automotive design and tribology. As we are aware of, a braking system of any vehicle is very important because it is helping the vehicle to stop, decelerate, or hold it in the right position. So, with this particular function of a braking system, let us all understand the requirements of a good braking system. First of all, it should have a good deceleration ability. So irrespective of the vehicle speed, the vehicle should be able to get slowed down with the help of the brakes. Second thing is the energy absorption. As we are aware of, any movable vehicle or movable object will have kinetic energy, and at the time of stopping it is getting converted to potential energy. This energy conversion should be taken up by the braking system. By the way, the energy conversion should be successfully done without much of wastage. Third thing is reducing the driver's effort. As we all know, the old first evolution of braking system had a very strong and very hard to use braking system, but in current scenario we have multiple methods to reduce the effort of the driver. For example, we have vacuum booster or we have hydraulic boosters to reduce the effort of the driver, thereby the driver's fatigue can be reduced. And the fourth one is holding the vehicle in its right place. As we are aware of, during the uphilling or downhilling condition, the vehicle has to be held in its place in order to avoid rolling from the particular surface. So this should be the final thing to be ensured to have a good braking system. Then about the stopping distance. The stopping distance generally consists of two important things. One is reaction distance, whereas the other one is braking distance. This particular image clearly depicts us the two different components of the stopping distance. So as the image tells us, the car driver is able to see the hazard even before the crossing of time. The vehicle should have gone through some distance. So this particular distance is known as reaction distance, that is between the vehicle driver has seen the particular obstacle to how long his brain is processing to apply the brakes. So this particular timing is known as reaction distance, and followed by after application of brakes, the vehicle takes a little longer to stop from the particular brake applied condition. So this condition is, or this distance is known as braking distance. So as I explained you in the diagram, the reaction distance is the distance you travel from the point of detecting a hazard until you begin braking or swerving. So this clearly tells us that before braking, the driver needs some part of the reaction time, only then he could able to stop the vehicle in time. So the reaction distance is affected by the car speed especially. So here if it is two times the speed, the timing is two times, which in turns converting into two times longer the reaction distance. The speed is about five times. Obviously the reaction distance also increases by five times. Some interesting facts about reaction time are, normally the reaction time ranges from 0.5 to 2 seconds, but the optimistic people in this particular activity is people who have their age between 45 to 54, because they have good eyesight as well as good experience in stopping the vehicle in the right time, so they have good decision making power. So as we all know, the young champs from 18 to 24 years, so we may think that they have the maximum eyesight and efficiency to stop the vehicle, but the major thing is they are lacking in experience. So this is resulting in the reduced the increased reaction distance in the case of young drivers driving the vehicle. Stopping distance can be affected or it is decreased by anticipation of hazards. If the driver is able to anticipate the hazards well in advance, that will help. Second thing is preparedness. If the driver is good enough to apply the brakes in any of the critical situation, these two things are very important to reduce the reaction distance. But in contrary, the reaction distance is increased because of the confusion in decision making. Especially the decision making should be very crisp, only then he would able to properly stop the vehicle. Second thing is consumption of any kind of alcoholic or drugs or any kind of medicines which is having the drowsiness. So because of these things, the reaction distance or reaction time may increase. Then tiredness, if the driver is driving for a longer period of time, so definitely it would have resulted in its fatigue. Because of the same, the driver could not be able to decide well, so which results in increased reaction distance. So the reaction time can be calculated by the formula D is equal to S into R divided by 3.6. So here D is reaction distance to be found out, and S is the speed in kilometers, R is the reaction time in seconds, and 3.6 is the fixed number to get converted from kilometer per hour to meters per second. So one example is given there. So if the vehicle is having 50 kilometer per hour speed, and if the reaction time is taken as 1 second, which becomes 50 into 1 divided by 3.6, so totally 13.9 meters is the reaction distance in this particular case. Next, the second component is braking distance after the brake has been applied. Yeah, the braking distance is the distance the car travels from the point when you start braking until the car stands still. So here the braking distance is affected by four major factors. First thing is the vehicle speed. So here it is the quadratic increase in when we compare with the reaction distance. For example, here if the vehicle speed increases two times, so there is a four times increase in braking distance. Similarly, if the vehicle speed increases by three times, it is nine times longer the braking distance. So this is about the increase of braking distance with respect to vehicle speed. Second thing is the road's condition, especially if it is uphilling, the vehicle will have even more lesser stopping distance. But if it is a downhilling kind of condition, obviously the slope in turn creates longer braking distance, so which should be taken into account. And the condition of road, that also very important. If the road is having good asphalt, then obviously the grip levels are more. But if the road is slippery or if it is raining, definitely it would have resulted in longer braking distance. Then load. So load major factor plays a vital role here, because as the load increases in the particular vehicle, obviously the braking ability decreases. If the driver alone is traveling in a car, that car will stop at comparably lesser distance, and if the car is fully loaded with people and cargo, obviously it results in longer braking distance. Next thing is the brakes condition. So the condition of the brakes or the braking technology, whether it is having ABS or it is having front disc brakes and rear drum setup or all around disc brake setup, all these things plays a vital role in stopping the particular vehicle in this stipulated time. So these are also major functions which plays a vital role in braking distance. So here we have the calculation of braking distance. So here the formula is D is equal to S square by 250 into F. So here S is speed in distance, speed in kilometer per hour. 250 is the fixed figure, and F is the coefficient of friction. So it is chosen from a range where 0.8 is taken for dry asphalt and 0.1 for ice. And if we assume the condition to be good tires, good brakes, and in good dry asphalt, then the vehicle which is traveling at 50 kilometer per hour on dry asphalt will have 50 square by 250 into 0.8, which results in 12.5 meters braking distance. So this is about the braking distance. Hope this video was really helpful to you to learn about the braking distance, reaction distance, and overall how the stopping distance of the vehicle is actually calculated and manipulated. So thanks for watching this video.